So we are going to try Khan Academy's Unit 8 test, all about applications of integrals. This test, we got 20 questions. They expect us to do this in 20 to 40 minutes. It's like 2 minutes a question. I don't know if that's a good thing or a bad thing, but we're going to try to do it anyway. And like always, I'm not getting off a stream until I get one wrong. So with that being said, we're about to do some calculus. Send this to somebody who you know takes calc or is about to take calc. Let me get a double tap if you're ready, and let's do it. Okay. So this question, it looks like it's talking about the length of a graph, so arc length. And it's asking which of this gives the length of a graph. So before I do anything for number one, I am just going to choose to write the formula for arc length of any function f of x from a to b. That way, if I got my formula right, then I can't really go wrong. And this formula I know is, I'll write it like this: the square root of 1 plus f prime of x squared. The derivation of that is actually not too bad. But that'll give you the arc length of f of x. And we don't even have to do any work really, because they give us f of x and they give us our interval, which is their x value. So it should be from 1 to e, which doesn't help us because all the answer choices say from 1 to e. But it's that, and then it'll be the square root of. All right. I want to go d off rip, but I'm sure it's not that easy because d is the only one that says 1 plus something, but it probably will simplify. So let's go 1 plus, and then it tells us that y equals what? X ln of x, or x times ln of x. So we just got to get the derivative of that, which should be, appreciate the likes. So I'm going to go what? Product rule, which says first times derivative of the second plus derivative of the second. Hold on. Let me make sure I did that right. First times derivative of the second plus derivative of the first times the second. There we go. So that really just becomes 1 plus ln x for the derivative. No, this is calculus. This is calculus BC. But there is a lot of algebra in it though. But all right, so we're going to take that f prime, which was 1 plus ln x, and then we're going to square it. So even though this isn't an algebra test, this problem is like 90% algebra. All right, so we're not done yet because nothing that I have is an answer choice. So I'm going to take that 1 plus ln x, and I know it's squared, so I'm going to take it and multiply it by itself. So this should look like this: the integral from 1 to e of the square root of, so I'm going to go 1 plus, and then I'm going to write it out. I'm not going to skip steps. This is going to be 1 plus ln x times itself. 1 plus ln x. So I'm going to FOIL that, and then hopefully something will cancel out. Let's see. So from 1 to e. Yeah, there's a lot of algebra, bro. Calculus is like 75% algebra. Okay, so what math class do you take? So this will be the square root of, we'll go 1 plus. All right, if I go FOIL, this will be outer. No, that's my first. My outer would be ln x times 1. My inner would also be ln x times 1. So when I combine those, that'll give me 2 ln x. And then plus my last will be ln of x, this whole thing squared, dx. All right. So can I compare that to any of my answer choices? Yep, it's looking like answer choice B. I'll simplify it still, but this is literally the integral from 1 to e of the square root of, obviously my 1 plus 1 gives me a 2, but look, I got a ln squared of x. I don't like how they wrote that, but I got a ln squared of x plus 2 ln x plus 2 dx. So what I got is answer choice B. Oh, bet. So you're done. You're done with school. What I get? B. Okay, bet. Okay. Um. Let's see. Number 2 is talking about particle motion. Um. Okay. All right. Oh, bet. Nice. 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 Okay. So it says Alexi received the following problem: a particle moves in a straight line with a velocity. At t equals 2, the particle's distance from the starting point was 5. What is the total distance traveled between 2 and 6 seconds? Which expression should she use to solve the problem? Okay, well, I'm going to say A. The reason I think it's A is because if we integrate velocity, you get displacement. But since it's the absolute value of displacement, that is total distance traveled from 2 to 6. Yeah, that should be it. If it's not, I'd be shocked. Let's see. Okay, bet. All right, number 3. What is the value of g of 4? Okay, we can use a calculator. This one should be light work. All right, let's try it. So, yeah, Khan Academy, it's a good website, bro. It's free. It has every type of math from like literally like kindergarten through like middle of college, literally. But okay, so for this question, I know that the integral of g prime of x dx from, let's see, the two x values of interest are -2 and 4. So I'll go from -2 to 4. According to FTC, this is equal to this right here. G of 4 minus g of -2. And then they tell us that g of -2 is 5. So g of 4, which is what they want, minus g of -2, which they say is -5. So minus -5 is the same thing as plus 5. And then the integral of g prime, I'm going to do that with a calculator. Let's see here. I'm going to go Desmos. And then we are trying to find the integral from, what was it, -2 to 4 of that function, which was x squared over cosine squared of x plus 1. X squared over cosine squared of x plus 1 dx. Let me make sure that's correct. Okay, I'm going to put these in parentheses just to be extra sure. I'm going to AP Pre-Cal. Will it be easy? No. I'm not going to lie to you. AP Pre-Cal is not easy. Of course, that's like a hard question to generalize, you know, because different people have like different skill sets and whatnot. But from what I've seen, I as an AP math teacher, I wouldn't consider it easy. But it is like possible to do really well. But it also depends on like the quality of the teacher and like how your algebra skills are and stuff, you know. So, but okay. The calculator tells me that this left side of the equation comes out to, I think they wanted us to round to like 3 decimal places. Yeah. All right. So this is going to be 15.651. All right. And then that equals g of 4 plus 5. So all I got to do is subtract 5. And then I will have my g of 4. So that should be what? 10.651? Because 15 minus 5 is 10. All right, that's what I'm claiming my answer is. Okay. Do we have to type in our? Oh yeah, we do have to type in our answer. Let me double check. All right, so we're integrating from -2 to 4, x squared over cosine of squared of x plus 1. Okay. I'm going to be extra careful. Okay. And then they say g of -2 is 5, -5. So minus -5 is plus 5. Okay, so we should be good. So I got 10.651. Okay, are we correct? We are correct. Let's go. All right. Next question, number 4. Consider the following problem. The velocity changes at a rate. Okay. At t equals 6, the velocity of the pendulum is 0.8 meters per second. By how much does the velocity change between? Okay, so just due to the wording of the question, I can tell what type of question this is. I love math, want to be good at it, and been pretty good at it. Okay, nice. Yeah, if you have a good teacher, bro, and you have like a good work ethic and study habits, then it's not gonna be like some impossibly hard class. So yeah, I wouldn't worry too much about it. But the stuff that I'm doing right now, you won't see until the year after this upcoming year. All right, so I want to integrate from 6 to 12. By how much does the velocity change? Oh, they don't want us to actually figure it out. It's just an expression. Okay. So I'm going C. Yeah, definitely not B, definitely not A. I mean, definitely not D. Answer choice A. That just gives us a difference in. Ooh. Oh, no. It's not A prime. We don't want jerk. Okay, I'm going answer choice C. Yeah, I don't know anything else it could be. Just the fact that I drew my integral sign before looking at the answer choices kind of confirms my answer. Let's go. All right. What number are we on? We're on number 5. We got 20 down. Let's keep going. All right, I'll erase that. I don't really need that. Number 5. Okay, it says the base of a solid S is the region bounded by the eclipse. Okay, the base of a solid is that ellipse. Okay. Cross sections perpendicular to the y-axis. So let me sketch this out real quick. If my ellipse looks something like this, my cross sections are perpendicular to the y-axis, so they're going to run side to side like so. And then those cross sections are isosceles right triangles with the hypotenuse lying in the base. Okay. So essentially what that means is there are triangles like so. I know my drawing is not really easy to see, but I'm trying to draw the isosceles triangles that like whose cross sections make up this solid. And so essentially all I got to do is figure out the area of one of these triangles. Hold on, let me make this a little skinnier. Find the area of one of these triangles, and then I just integrate that from, let's see, if I'm perpendicular to the y-axis, so my bounds should be y values. So that means they're going to go from -2 all the way up to, I'm guessing, +2. Yeah. Okay. So, yeah, we just need to figure out the area of one of these triangles. All right. So triangle area, I know this. We're going to pretend that this is an isosceles right triangle. It did say right? Yeah. All right. So I know these two legs are the same size. And then, so if I draw, I know there's a formula to find the area of such a triangle, but I don't remember that formula. So I know this distance right here is half of my base. And let's see here. If I want that distance, they don't give us any formulas either, do they? Nope. Okay, so if I know two sides, I know I can get the third side, which is the height, and then I would already know half of the base. But my question is, how do I get the base from that formula? I'm going to look it up because I don't feel like trying to sit here and derive this. So I need to look up the area of a isosceles right triangle. Let's just look images. Oh yeah, the base and the height are the same. Well, it's not that the base and the height are the same, but these two sides are the same, and they could act as the base and the height. But we just need to find one of those though. What math are you taking now, Julian? Because it definitely does get a lot more crazier than this. Okay. So let me draw my picture a little bit more clear. Hopefully we can find this. DiffyQ, man, DiffyQ was like one of the few college classes that I remember like surprisingly doing well in. Out of all my upper division math classes, I understood that one the most for some reason. But I also had a really good TA. So that had a lot to do with it. All right. Appreciate that share too, by the way. Okay, so I wonder what would happen if I like solved for X. But actually, if I know the X's go from -3 to 3 and the Y's go from -2 to 2, I'm trying to get the area of this triangle right here. The hard part about these is once you do get the area, the problem is pretty much done. It's just getting the area that can be the tricky part sometimes. Okay, so I got to figure out how to not get the two legs, but the hypotenuse. I got to look up the anatomy of an ellipse, I feel like, to further understand this. Specifically as it relates to like the equation. Oh, you know what? That's right. I forgot it's common to make ellipse equations equal 1. So if I did that, let's see. What would A and B give me? So I gotta get. So this base. Negative x to x. So I guess 2x. Okay, let's try this. If I take out the ellipse, if I label this as 2x, let's call both of these like A. Okay, let's try Pythagorean theorem and see what happens. Because I just got to solve for A. So let's go 2A squared, because that's A squared. Let's just do it like this. A squared plus A squared is 2A squared equals 4x squared. Okay. So in that case, if I'm solving for A, I just divide both sides by 2. And get this. And then if I square root both sides, I get this. Okay, so I need to go 1/2 times that times that. So area equals 1/2 times 2x squared. And then that'll become 4x squared. So this is really just 2x squared. Yeah, we're just adding up a whole bunch of areas. Because that's 2x. Base times base. That's at 2x squared. And then half it. Hold up. If a squared is this, then we want half of that. So that should just be x squared. Yeah, x squared. I was gonna say, how did I get? Oh, I squared the 2 when I didn't need to. That's what it was. Okay, I knew I should get x squared, but I wasn't getting it. Okay, so if I integrate that, that should give me my answer. So that's what? X cubed over 3 evaluated from -2 to 2. Actually, hold up. Because these bounds that I'm integrating from are y values. So my x squared needs to be in terms of y. I almost messed up right there. And that's only because my cross sections are perpendicular to the y-axis. So yeah, my function needs to be in terms of y. So I'm going to rewrite this like this. I'm going to say the integral, still from -2 to 2. but I'm going to figure out a way to figure out what x squared is equal to in terms of y. And I'm going to do that from here. So I guess I would start by going 4x squared equals 36 minus 9y squared. And then dividing everything by 4. That should get me what I need. Hopefully it's nothing too crazy to integrate. So that'll be x squared is equal to okay, so once I do that, and then I should just be able to integrate that from what, -2 to 2, and that should be it. All right, so I got 9 minus 9/4 y squared. That should be what I'm integrating, since it's in terms of y. So I'm going to try that. Okay, so that should be equal to 9y minus 9/4 times y cubed over 3 from -2 to 2. All right, let's see what that looks like. So that'll be, my first iteration would be 9 times 2 minus 9/4 times 2 cubed over 3. All right, minus my second iteration, which will be 9 times, appreciate the follow, 9 times -2 minus 9/4 times -2 cubed over 3. All right, hopefully I'm doing this right. Whatever I should get from here should be my final answer. Let's see. So I got 18 minus. All right, so that, let's see, what could I do? I could cancel out my 9 and my 3 to just make a 3. Times 2 cubed is 8. Okay, so let's work smarter, not harder here. So I got a 3 on top, and then I got a 8 on top, and then a 4 on bottom. So 8 over 4 makes 2, and then the 2 times 3 makes a 6. So I'll do that. Minus, right, 18 over 3. I mean 8 over 3. Yeah, that should be right. And then I got a -18. And then this one should be a plus because I have two negatives being multiplied by each other. This time I got a -8 on top over 4. So that's plus 2 times 3. So that should be a plus 6. All right. So that just becomes 12 minus -18 plus 6 should be -12. Okay, so final answer should be 24. At least that's what I'm getting. If it's wrong, I don't know where I messed up, but I'm going to go for 24. Hopefully that's right. Let's go. Okay, that one was kind of annoying just because trying to figure out or just realize that that base, I guess, was 2x. Is that how they did it? Yeah, 2x. Okay. All right, well, we got it right. Let's go. Okay, so next question says the approval rating of a certain politician is changing at a rate of R of T% of the population per month. So R of T is a rate. Therefore, the integral of this rate represents, it should be without reading the answer choices, the accumulation of percentage or something like that. Not B, not C, not D. Yeah, it should be A. Yeah. Definitely not an average rate of change. It's not a rate of change. Yeah. Okay, bet. All right, number 7. Ooh, we're getting moving right along. All right, number 7. What is the area between the graphs of f of x and g of x from 1 to 4? You might need a calculator. Okay. Well, if they're letting me use a calculator, I don't know, like, to what extent. I mean, see, the thing is, I can use Desmos for this, or I could do it by hand. I guess I'll do it by hand. So first, the thing I got to do is figure out where these two graphs intersect, because at intersection points, what's on top and what's on bottom usually changes. So I'm going to first figure out at what x values are these two graphs equal to each other. And just from the looks of it, this should be pretty easy to do algebraically. And we're only considering from 1 to 4 too, so that's good. All right, so if I were to subtract x squared from both sides and subtract 12x from both sides, I would have a 2x squared minus 12x plus 10. I'm going to factor a 2 out, so that'll give me x squared minus 6x plus 5. I can factor that some more. I'm thinking -5 and -1. So when I solve for that, x equals 5 and x equals 1. Okay, so what's on top and what's on bottom actually doesn't even change, which is good. We just got to figure out what's on top and what's on bottom. So between 1 to 4, I'm going to pick an x value in that region and see what is the bigger y value between f of, let's say, f of 2 compared to g of 2. Because we got to go top minus bottom, and whichever y value is bigger, that's what's going to be on top. So f of 2 would be 2 squared, which is 4, plus 12 times 2, which is 24. So that's 28. And then g of 2 is, appreciate that follow, that is going to be 3 times 2 squared, which is 4. So 3 times 4 is 12, plus 10. And that should be a 22. So it looks like f of 2, or f in general, is on top. So when I integrate, it should look like this. My top function, which is x squared plus 12x, minus the bottom function, which is 3x squared plus 10. Okay. So literally I just got to integrate this, and that should be my answer. So I'm going to simplify this first, though. That'll be the integral from 1 to 4 of, let's see, this right here, it's Calc BC, so it falls under Calc 2, but a lot of the questions in this unit are Calc 1. So kind of both, to answer your question. So this becomes what? 1 minus 3 is -2. And then I got a minus 10 and a plus 12x. That should be correct. Calc 2, yeah, man, it's not bad so far. After this test, I'm about to get into like parametric equations and polar equations, and then onto series and stuff. So that's when it's really kind of going to get sweaty. But all right, let's see here. So this should be -2 over 3x cubed plus 6x squared minus 10x, all to be evaluated from 1 to 4. All right, so that should be -2x squared plus 12x minus 10. We did top minus bottom, so I think we should be in good shape. All right, let's try to plug in. So the first plug in will be -2/3 times 4 cubed plus 6 times 4 squared is what? 16 minus 10 times 4, which is 40. And then my second iteration, I'm just going to replace x with 1. So that'll be negative 2/3 plus 6 minus 10. All right, so whatever all of that comes out to be should be my final answer. And they do yet let me use a calculator, so I'm going to go ahead and do that. Let me pull up my calculator. All right, so 64 times 2, 128 divided by 3. I'm just going to leave everything over 3. So this will be negative 128 over 3 plus 6 times 16, 96. Let's do it like this. 96 times 3. So 288 over 3 should be my 96. And then minus 120 over 3. Appreciate that share. Hopefully we can get 100% on the first go around. All right, so all of that is going to be subtracted from, let's just type it in, negative 2/3. Then we're going to go plus 6 and then minus 10. Put that as a fraction. That is negative 14 over 3. All right, let's calculate. So I got, let's see here, negative 120. Actually, I'm gonna just do 288 minus 120 minus 128. Oops. All right, so I got 40 plus 14. So that should be 54 over 3 for my final answer. And I think that was an answer choice too, by the way. Let's see here. Oh no, it wasn't an answer choice. I did something wrong. Okay, I could go A. Actually, wait, did I mess up? 40. I feel like it is A, but I'm not about to chance it. Hold on. Wait a second. I got 54 over 3. That turns into a whole number. That is divisible by 3. 18. Okay, wait. I'm not tripping. I seen that over 3, and I thought my answer had to be over 3, but it is over 3. It just simplifies to 18. But is it right? Let's go. All right, next question, number 8. Let region R be enclosed by this parabola and the axes in the first quadrant. Region R is the base of a solid whose cross sections perpendicular to the y-axis are squares. Okay, so from just reading that sentence, I know that my bounds have to be y values. So my answer has to be the integral from 0 to 3. I know that. So it's already either B or C. And then I just got to figure out the area of a square. And if they're giving us y equals already, then I just, well, I needed to say x equals. And I do think it'll still be squared. So I'm going to go B, but let me work it out just to be safe. This is number 8. So we know that y equals 3 minus x squared. And we are tasked with getting x by itself. So I got to add x squared to both sides and then subtract y. So that'll be that, meaning that x equals, actually, you know what? If x equals the square root of 3 minus y, that's a side of a square. So I would just square that. So 3 minus y is already squared. So I actually take my answer back. It's going to go C. Reason is, I'll show my work still. because this square root of 3 minus y is my expression or my curve, and that x value is going to act as the side of a square. So to get the area of the square, I got to multiply this by itself, giving me just 3 minus y. So that's what I would need to integrate. So I'm going with answer choice C. And again, the reason I'm not going A is because my bounds need to be y values, because my cross sections are perpendicular to the y-axis. So my cross sections are like stacking vertically instead of horizontally. Let's go. Okay. Number 9. We're almost halfway, bro. Okay. So we got, as a particle moves along the number line, its position is s of t, velocity is v of t, and acceleration is 12t minus 4. Okay, so we know that the integral of 12t minus 4 dt is my velocity function. Yeah. So we know that the integral of acceleration is velocity plus c. Okay. And I can integrate that relatively easy. That should just be equal to 6t squared minus 4t plus c. That is my velocity. And then we know that the integral of velocity is position. And two x values that we're interested in. Ooh. Hold up. We need to figure out c. Because they're telling us that v of 2 equals 4. So let's do that first. Let's figure out the c for my velocity. So if that's v of t, and we know my velocity equals 4, whenever my t is 2, I can figure out t. So I'm solving for c right now, so I know my full velocity. Once I do that, I can integrate that from 0 to 1. So this becomes 4 equals 6 times 4 is 24 minus 8 plus c. Okay, so c should be negative 12. I'm going to double check all that because I went through that way too fast for my personal liking. 24 minus 8 should be 16. I'm going to check just to make sure, because I do not need this being the reason why I missed one. And then 4 minus 16 is negative 12. Yes. All right, so I got my c. So here's what I know for a fact. I know my velocity is equal to 6t squared minus 4t minus 12. And notice how if I derive that, I would get 12t minus 4. But all right, so now I know the integral from 0 to 1. And I know 0 to 1 because those are the two t values that it gives me. My integral from 0 to 1 of my velocity is literally by ftc equal to s of 1 minus s of 0. I'm trying, man. I'm trying to get a 100 the first go around. I'm on number 9. I got 20 total, so we'll see how this goes. All right, so boom, that's my FTC formula. S of 1 is what I'm trying to find, so I'll leave that as is. Minus, they tell us S of 0 is 1. And then the integral of my velocity, I can easily get that. That should be 6t cubed. That should be 2t cubed. Minus 2t squared minus 12t. So I got 6t squared minus 4t minus 12. That last t I know is hard to see, but it's there. But oh, we need to evaluate that from 0 to 1 though. That's the annoying part. So I'm gonna do this. Slide this over real quick. Then I need to evaluate that from 0 to 1. Okay, that's what I need to do. So evaluating this at 1, that'll be 2 minus 2 minus 12 minus 0 equals s of 1 minus 1. So 2 minus 2 is 0. 0 minus 12 is negative 12 equals s of 1 minus 1. Add 1 to both sides, you get negative 11. Oh, I'm nervous. I went through that, I feel like, too fast. I think that is my answer, but I'm going to double check real quick just to make sure. So what did I do first? They gave us acceleration. I integrated it as an indefinite integral to get my velocity function, which is right here. Okay, and just to check, if I derive that, I do get 12t minus 4. I need to figure out my plus c. So I use the fact that v of t equals 4. So I set my velocity equal to 4 when t was 2, and I use that to solve for c. 6 times 4 is 24 minus 8. 24 minus 8 is 16. 4 minus 16 is negative 12. So I got my velocity function. I integrated it from 0 to 1. That is one thing I could check. I'm going to check it just to be safe, because why not? Integral from 0 to 1 of my velocity function, which was 6t squared minus 4t minus 12 dt, and I did get negative 12, and then I add 1 to that, and I got negative 11. So let's go. Whew. All right, we have yet to miss one, y'all. All right, we got an area between two curves. They're both x equals, so that's good. Which expression represents the area bounded by the curves? All right, we got this. So I know, since they both start with x equals, my bounds are y values. So from 1 to 11, visually, just can't be it. So it's either A or B. The difference is right minus left. I'm going to actually write this part out. So usually when there's two curves, you want to go, like, you want to do the top function minus the bottom function. But since these curves are both in terms of x, there's no top and bottom, but rather there's a right and a left. So what I suggest is calculating the right function, which is the blue, minus the orange. So the right function is negative y squared plus 3y plus 11. And we're going to subtract, parentheses, the orange function, which is y squared plus y minus 1. And then they're going to simplify that. And then whatever that simplified version comes down to, that should be my answer. So already I'm thinking it's A. Because look, I got a negative y squared minus a y squared. That's negative 2y squared. And A is the answer choice with a negative 2y squared. But if I were to keep going, I got a 3y minus a y, which is a plus 2y. And then I got an 11 minus a negative 1, which should be a plus 12. And look at that. Negative 2y squared plus 2y plus 12. So I'm going to go A. And then my negative 2 to 3, those look like my y bounds. Let's go. All right, we're cooking. Number 11. What is the area of the region between these two graphs? Okay. They're letting us use a calculator, but no, I'm not going to do that. Let's do it the right way. Let's set these two equations equal to each other. so we can find their intersection points. So it's a curve and a line. Okay, so let's just solve this real quick. So that'll be x squared. If I subtract 2x from both sides, the 2x's cancel, so I just get x squared equals 1, which leads to x squared minus 1, which I know x is plus or minus 1. Okay. Yeah. All right, so from here, well, those are my bounds. So now all I got to do is integrate from -1 to 1. I got to see which function is on top and which one is on bottom. In order to do that, since my interval of interest is from -1 to 1, I'm going to take a x value that's in between that. So I'm going to take 0 because that's an easy number to plug in. I'm going to take f of 0 and I'm going to take g of 0, and whichever is the larger output is going to be on top. So f of 0 is 0, and then g of 0 is 1. So my g of x is going to be on top, so I'm going to do that function first. So, excuse me, it'll be 2x plus 1. Subtract my bottom function, which is x squared plus 2x. dx. All right, now before I integrate, I'm going to simplify. So this becomes, let's see, negative x squared. 2x minus 2x cancels out, and then I got a plus 1. Yeah, this looks right. All right, integrating this, I will get negative x cubed over 3 plus x, evaluated from -1 to 1. All right, so let's see. When I plug in my 1, I get a -1 over 3 plus 1 minus, and then I got a -1, because -1 cubed is -1, but negative that is going to be a positive 1 third plus -1, so I guess minus 3 over 3. All right, so this is what, 2 over 3 minus 1 minus 3 is -2, so minus -2 is the same thing as plus 2. So I am getting an answer choice. 4/3. Am I correct though? Let's go. All right, moving right along, number 12. All right, Chris, what's good, bro? We're past halfway through. I got 20 total. I'm on number 12. We haven't missed one yet. Let's go. Applications of integrals. All right, region R is enclosed by these two curves. Okay, they're both y equals. What is the volume of the solid generated when R is rotated about the x-axis? Okay, looking like a washer method type of question. So I have what I like to do on these is define like a little radius and a big radius. I know they already use capital R, but whatever. So my inner radius is going to be the shorter distance from the 2D shape and the x-axis, and that distance is the red graph. And so that distance from the x-axis to that graph is just going to be x squared. And then the bigger radius, or the outer distance, is going to be from the blue to the x-axis, and that is 4x minus x squared. All right, so what I got to do is I got to make two calculations. I'm going to calculate the outer area, and then, I'll calculate the outer volume and then subtract the inner volume. And what I want to do that is I just want to integrate from, it looks like, it tells me 0 to 2. And I want to take the bigger volume and subtract the inner volume. To get the bigger volume, it's going to be pi times that outer radius squared. Pi r squared. And we're just adding up a whole bunch of those. And then from that, I'm going to subtract also the integral from 0 to 2. But I'm going to subtract the inner volume. And I'm going to use my bigger radius. And I messed up. I just realized I messed up. Let me scoot this over real quick. I used my smaller radius first when I should have used my big radius. I mean, wait, so you're taking Calc 1 this upcoming semester or Calc 2? I say prepare for whatever you're about to take. That's my personal advice. So my outer, we said was that. Oh, you just finished Calc 1. Nice. Well, shoot. Oh, got you. Okay. Yeah, I say, honestly, I would say master integration and then get a head start on Calc 2. Because if you're not good with integrals and like the different integration techniques, then Calc 2 can be a bit of a struggle. So I would say master integration more than anything. That's just my 2 cents. But okay. Pi times the outer radius squared. I forgot my dx. Minus the integral from 0 to 2 of pi times the inner squared. All right. Now, truth be told, I do not want to use a calculator for this. And also, truth be told, on the AP test on questions like these, they're more so concerned about are you able to set it up versus are you able to calculate it. But I don't think, yeah, you could combine this into one. Since the bounds are the same, you can combine it into one. You'll get the same answer. But I don't want to do this by hand, bro. But I guess since we're being legit, Khan Academy doesn't give me a calculator on this one. So I guess I'll do it by hand. All right. So, Chris, based on what you said, which is correct, you could rewrite it as such. Let's see. So if I do U sub, it's funny you say that because as I was looking at this, I was just going to FOIL this part and not do U sub. But you could do U sub. But here's what I'm about to FOIL. Let me write it out. 4x minus x squared times itself. So that'll be what? 16x squared minus 4x cubed minus another 4x cubed. So that'll be minus 8x cubed plus x to the 4th. Appreciate that share. Okay, so that is what I'm integrating from my first expression. So I guess I'll write it like this. And then since that pi is also in this one, I can really just factor it out of everything. And then that'll be x squared is x to the 4th. So this actually doesn't become too bad. All right, let's see here. So we are integrating. If I subtract the x to the 4th, or if I combine them rather, they will cancel out. So my final integration is this right here. That'll be what? Negative 8x cubed plus 16x squared dx. Okay, so that'll be negative 8 x to the fourth over 4. So negative 2x to the fourth plus 16 over 3x cubed. Evaluated from 0 to 2. Don't forget that pi. Okay. This is Calculus BC. Or Calculus 2 if you're in college. Okay, so this would be negative 2 times 2 to the fourth. What's 2 to the fourth? 32. No. 16. Because I know 2 to the third is 8. Plus 16 over 3 times 8. Because that's 2 cubed. And then when I subtract 0, everything just goes away. So that's what I'm getting. Double angle theorem. Oh yeah, that one's a sleeper. I forget about half angle and double angle. I still to this day never memorized it. Okay, so here's what I'm gonna do. I'm gonna write it like this. Since both terms have a 16 and a pi, I'm gonna go like this. Right, that's still negative 2 pi times 16 plus pi times 16 times 8 over 3. Yeah, that's correct. But instead of putting a 2, I'll put a, what, 6 over 3? So that becomes 16 pi times 8 minus 6 is 2. So I get a 2/3 times 16 pi. 16 times 2 is what? 32? All right, I'm ending stream if I get this wrong. I'm about to crash out if it's wrong, but it should be right though. I know I did a lot of steps, but let's go over it real quick. So I got my big radius. I got my little radius. Those look good. Pi, remember to square each radius. Okay. Combine them, turn them into 1. Okay. I mean, it looks good. Let's just try it. Let's just try it and see. If we get it wrong, we get it wrong. 32 over 3 times pi. Now, I did do a lot of mental math. Let's see here. 2 times 16 is 32. 16 times 8 over 3. Yeah. Let's see. Let's go. Okay, I was glad I got that one right. I'm not surprised, but I'm glad I made no mistakes. All right, we're on number 13. The shaded region is bounded by the graph of the function f of x equals 2 over x, and then the lines x equals 1 and x equals e squared, and the x-axis. What is the exact area? We know how to do this. This is easy. Number 13. Okay, so we're trying to find the exact area, so that means we want to integrate from 1 to e squared. And the function, yes, this is BC. And the function that we are trying to integrate is simply 2 over x, but I'm going to write it like so. That is literally all they're asking us to do for this question, I believe. Yes. Okay, so this becomes 2 times the integral of 1 over x is just a natural log of the absolute value of x. and we are evaluating that from 1 to e squared. Okay, so far things are looking good. This is equal to 2. Let's see. I'll go like this. Ln of e squared minus ln of 1. I know the ln of 1 is 0 because e to the 0 power equals 1. And then I know ln of e squared is 2 because e to the second power will give me e squared. So I guess I should do it like that. So my final answer should be 4. All right, let's see. Ln of e squared. E to the what equals e squared? 2 e squared. Yeah. All right, I'm getting 4. Hopefully it's 4. If it's not, I'm about to cry. Let's go. Whew. We're almost done, y'all. We're getting closer. We're getting closer. All right, bro. If I miss one getting this far into it, appreciate that follow. I'm about to be sad. The population of a town grows at a rate of this many people per year, where t is the number of years. All right, this one's easy. I'm going to show a little bit of work on this one. Number 14. If we let P of t represent the population, actually I'm going to write it like this. Then we know P prime of t equals 2e to the 0.2t all minus t. That is in people per year. T is in years. How many people, by how many people did the population grow between 0 and 5? That is just this. The integral from 0 to 5 of my function. 2e to the 0.2t minus t. That is what they want us to figure out. I'll probably go u sub on that first term. Even though it's not really necessary, I'm going to do it anyway. And then du would just equal 0.2 dt. So if I were to rewrite this integral, or at least the first term of this integrand in terms of u, that'll just be like this. This problem now becomes 2 times the integral from 0 to 5 of e to the u dt. Or actually, no, du. But when I write a du, I have a 0.2. Oh, no. Hopefully, I don't know. Let me know if it would help if I did vertical streaming instead. But since that du involves a 0.2 that I don't want, I need to divide by that. So I need to go like this. That 1 over 0.2 cancels out the 0.2 that's in the du. So it's that, and then it's minus the integral from 0 to 5 of t dt. Okay. Spessa, appreciate that follow. Hopefully I don't miss one, man. All right, so this becomes 1 over 0.2. Well, 0.2 is 2 over 10. So 1 over 2 over 10 would be 10 over 2 times 2 times e to the 0.2t. Okay. And then that is evaluated from 0 to 5 minus t squared over 2. Reverse power rule from 0 to 5. All right, so this is what? 10 parentheses will go e to the power of 0.2 times 5. Now remember, 0.2 is 2 over 10 times 5 will be 10 over 10, which is just 1, minus e to the 0.2 times 0. All right, so I got that. Do I have a math degree? Yes. I graduated from the University of Texas way back in 2015. Long time ago. Okay, so boom, and then I'm gonna subtract. I'll go 5 squared over 2, which is 25 over 2, minus 0 squared over 2. All right, let's see if we get something. All right, let's see here. I'm getting 10e. That's interesting. I'm glad there's answer choices on this one because I most definitely did something wrong. This is baby food. This should be. But I'm trying to figure out where I went wrong. 10e minus 25 over 2. Oh, it is. It does say approximately, so I'm not all the way cooked. So we can use a calculator to see what is 10e minus 25 over 2. I'm just going to use Desmos. Let's see if I get anything remotely close. 10e minus 25 over 2. I got 14.6. That is pretty close to 15. I'm just saying. Let's go for it. I missed one. What did I do wrong, bro? That one should have been easy. I'm actually salty. No, bro. I wanted to go perfect score. How did I miss this one? I bet you it was something small, too. That's so tough. Dang it, bro. This is frustration. Where did I mess up? E to the 0 is 1. Bro, there's no way. There's no way I messed up on e to the 0. Bro, Ray. Did I just really go out sad like that over e to the 0? Bro, that's tough. That's so tough. That's so tough. Bro, dog, I was doing so well. How do I miss? Bro, every time I miss stuff, I miss the easy stuff, bro. I grade assignments to catch something like that. Bro, I'm literally about to cry on stream, bro. I don't know what I was thinking. I just seen e to the 0 and my brain just said 0. I don't even know. I don't even have an excuse. That is tough. That is tough. Well, I guess I'll still finish the problem because why not? So this is really e minus 1. That's so frustrating, bro. Minus 25 over 2. Bruh, there's no way. This is not real. I'm doing this tomorrow, bro. I'm not trying to redo this. I'm not. I can't do it. I can't. What is this? 10 e minus 1 parentheses minus 25 over 2. 4.6.